complex concept. Two unit times for which projectile is of the same height. Now you can take, let us you can take it is a horizontal. One projectile is projected into a conventional velocity u, and it makes an angle theta with the horizon. Now resolve this velocity along this direction. So u cos theta and u sin theta. Now the trajectory of the projectile may be moving in this direction, and this reaches the ground. Now you can take an at a certain height h. So two different points. Let us take in these two with the points, and here point A B will be there, and here point B will be there, and this horizontal height you can take as the horizontal height is h. Now initial velocity along y direction is u sin theta, and the acceleration due to gravity is acting down z. Therefore, height is above the principal axis, above the horizontal. Therefore, plus h equal to, so u sin theta times of t minus half g t square. Therefore, you can take t square minus 2u sin theta divided by g plus 2h divided by g, that must equal to 0. It is the quadratic equation in terms of t. So if you take in two different types, so here you can take in time t1 and here you can take in time t2. Therefore, the roots of this, sum of the roots of this quadratic equation you can take in t1 plus t2. It is a minus v by 2. That is 2u sin theta divided by g. Take this equation number 1 and product of the tools. So you can take in P1 and P2. So it is the coefficient C divided by T, C divided by A, that is 2H divided by G. So take this equation number 2. Therefore, the time difference between these two uh, points, you can take in P1 minus P2, that equal to under root P1 plus P2 whole square minus plus or minus 4 times of P1 P2. So if you take in P1 plus P2, that is 4 u square sin square theta divided by g square minus 4 times of 2h divided by z na, therefore 8h divided by g. So it is your time difference. So if you are using equation 1 and equation 2 and equation 3, so you can take in it is equation 1 and equation 2 and equation 3. So you can find out P1 values and the P2 values. Now, the if you know the difference between these two time differences and the distance, horizontal distance between the two different points you take as x, therefore x equal to horizontal component of velocity. So u cos theta times of time difference. So the time difference already you know that is under root 4 u square sin square theta divided by g square minus 8x. Therefore, horizontal distance is u cos theta times of under root 4 u square sin square theta divided by g square divided by g square minus 8h divided by g. So it is the horizontal separation between the two points of the same height at a given arbitrary. Next topic will go with radius of curvature of an oblique projectile. Radius of projectile of an oblique projectile. Let us say it is over horizon. Now, here one projectile will be projected with a potential velocity u, and it makes an angle theta. Now, project trajectory of the equation will be moving in this direction. So, and again it will reach the ground like this. See, at this point, velocity of the projectile you can take it in this direction. Let's see. So, the particle at this location is purely under circular motion. So now the particle at this location is in circular motion like this. Now the particle will be moving in a circular motion with having a center at O. Now if you taken radius of this circle is taken as P as R, and we know that particle having a certain amount of acceleration g is acting downward, and here velocity makes an angle beta with the vertical. Therefore, if it is a 90 minus beta, and it is also you can take it as a. Therefore, uh, centripetal acceleration. Centripetal acceleration is v perpendicular square divided by r. So here, centripetal acceleration in terms of g. So you can take as v as g cos beta. That must be equal to, so v perpendicular square at that instant divided by radius of the circle. So we need to calculate radius of the circle, that is v square divided by g times of cos theta. So if you take radius of circle at the highest point, so if you taken it is your horizontal ground, and if your projected velocity is having a projectile at the maximum height, so you can take and be perpendicular is something like to u cos theta. So therefore, at this point, if you are consider the body will be circular, then radius of circular track you can take as s now. Hence, radius r equal to their velocity you can take in u cos theta whole square divided by, so acceleration you can take as s. So where beta you can take as 0. Therefore, cos beta equal to maximum. Next one, relative motion between two projectiles. See here, so relative motion between two projectiles. So let us you can take it is your horizontal graph. Now here you can see, so like this one projectile if you are taking, so two different projectiles you need to send from the point of projectile. So one projectile is A having initial velocity is UA and it makes an angle theta A with the horizontal. And one more projectile is UB and B that is projected in this direction with initial velocity you can take as UB and angle of projection you can take as theta. Now you can see this projectile will be moving in this direction and reaches the ground. And one more projectile, this projectile is moving in this direction and reaches the ground. Now here you can resolve definitely acceleration of A that equal to minus g and acceleration of B that is also you can take as a minus g means and along x direction accelerations you can take as c. These accelerations along y direction. Acceleration along x direction for both the projectiles equal to 0. Now here you can resolve velocity of u into two mutual perpendicular functions. That is, so ua cos theta a times of I cap plus ub sin theta b times sin theta a times of j cap. Similarly, velocity of b, initial velocity of b, so that is ub cos theta b times of I cap plus ub sin theta b times of j cap. Now here you can see initial velocity of b with a with respect to or initial velocity of b with respect to a that equal to, so initial velocity of b along cos theta, so theta b minus initial velocity of a along x component x direction times of I cap plus, so ub sin theta b minus ua sin theta a times of j cap. Now here you can see relative velocity of two projectiles will be constant, but relative acceleration that must equal to 0. Why? Because both are having the same acceleration. Hence, relative motion, hence, relative motion is uniform. Relative motion of projectiles is uniform. Now here you can see relative x component. So relative x component of b with respect to a. So you can take initial velocity of b with respect to a along x direction times of time t. Similarly, y component of b with respect to a, that is initial velocity of b with respect to a times of y direction times of t. Now you can take initial component of a, that is x component of a with respect to b divided or y component of b with respect to a divided by x component of b with respect to a, that equal to y component of b. So ub sin theta b minus ua sin theta a divided by ub cos theta b minus UA cos theta A. So that is remains constant. Therefore, relative velocity of projectiles with respect to each other is purely uniform. Next, the concept condition for collision between the two projectiles. Let us you can take it is your ground, and here one tower we need to achieve. So tower of height you can take as H1, and here one more tower we need to consider. So this tower of height you can take as H2. So here one body of projectile is projected in this direction with A. Let us this point we can take as A, and this point we can take as B. And this A, and it makes an angle theta A with the horizontal. Theta A with the horizontal. And here B is projected in this direction with initial velocity of B, and it makes an angle theta, or it is you can take as alpha, and it is you can take as a beta. Now here you can see relative acceleration between the A and B equal to 0. That is acceleration of B with respect to A equal to 0, or acceleration of A with respect to B. Let us you can take acceleration of A with respect to B equal to 0. Now here you can see acceleration of A with respect to B, or velocity. So velocity of, or initial velocity of A with respect to B, that is along x direction you can take. Now you can resolve A along x direction, that is UA cos alpha, and along y direction resolve, that is UA sin alpha. Similarly, B velocity you can resolve now, so UB cos beta, and along vertical direction, so UB sin beta. To collide here, two different particles, definitely UA sin alpha is greater compared with UB sin alpha. So the first condition to collide, so collide A and B, must condition is UA sin alpha. Why? Because A point is downside compared with B point. UA sin alpha is greater compared with UB sin beta. Okay. Now, if you take it is a point of projection is A, and here point of projection is B. Now, you can take in relative velocity of A with respect to B. Means in this direction you can take relative velocity of A. So U relative along x direction, that equal to, so UA cos alpha minus UB cos beta. Why? Because both are opposite to each other. Similarly, in this direction, so U relative along y direction, that equal to, so UA sin beta minus UB sin beta, sin alpha, sorry. So here sin alpha, so UA sin alpha minus UB sin beta. Now the separation between the towers you can take as x, and the separation between the heights, so you can take in h2 minus h1. Therefore, horizontal distance between A and B you can take as x, and vertical distance between the A and B you can take as h2 minus h1. So now if you are taking relative velocities to collide A with respect to B, na, definitely it is moving in this direction with certain velocity you can take as U relative. Now U relative along x direction you know, and U relative along y direction you know. Just you can find out U relative of A with respect to B. Therefore, that is under root U relative along x direction square plus U relative along y direction square. So therefore, if you are find out now U relative, so to collision between the two particles, so uh, time of collision. So time of collision. So time of collision you can take. So separation between A and B, you can take under root h2 minus h1 whole square plus x square. That is the separation between two points, and U relative. So U relative along AB direction. So it is your time of flight to collide to each other. Okay.